inversely proportional to t. Key phrase that you just read there? Inversely proportional. But my question is, what exactly does that mean? What does it mean if these two things are inversely proportional, Jennifer?
So if you use the equation y equals k over x?
Yeah, so y equals k over x, or y equals k times 1 over x. That's what we're going to get out of this inversely proportional relationship. All right, so Anthony, are we okay with the y equals k over x? All right, so the rate of change of b with respect to t, what is that? The rate of change of b with respect to t is, Anthony? It's what? It's slope, but how are we going to write that in a calculus way, in a differential equations kind of way? The rate of change of b with respect to t. Okay? You know what I mean? You want to take that one?
B of t.
Not b of t. We're missing the rate of change. The rate of change. It means only one thing in this class, and that is derivative. So I need the rate of change of b with respect to t, so that means db dt is inversely proportional to whatever comes after inversely proportional, t. So db dt is equal to k over t. Thanks, Jonathan. I would hope that now that the differential equation is set up, life gets good, and we get to go a lot faster. So next move. Anthony, what are we going to do? How are we going to get the t on the other side? Okay, we're going to multiply by dt. So db equals k over t dt. Have you separated the variables? Right, k is a constant. I'm not worried about the fact that k is over here. K is a constant. db, that's the variable. If there were any other b's, I need it over here on the db side. But there are no other b's. So now I'm on my favorite part. Integrate. 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 K is a constant. Take that constant out. Boom. K times the integral of 1 over t dt. Everybody knows that one?
Natural log of
Natural log absolute value of t plus c. Integral of db. It's just b.
Oh.
So b equals k natural log absolute value of t plus c. Then you're going to go through and it says if b is equal to 2 and t is equal to 1. All right, that's an initial condition. If t is equal to 1, b is equal to 2. And then b is equal to 4 when t is equal to e. That's another one. T equals e, b is equal to 4. Finish it off from there while I take attendance and do all the things. 3, 5, 7, 10, 14, 16.
Why do you
Why he used it? Did he give it to you?
why I'm trying to use
Yeah, he's on the first.
using that or something?
I think it's weird. No, it doesn't really matter.
All right, so for folks that didn't need help on number 4, what other questions were problems?
4 is E.
Edgar?
Can you go over again how, okay, so K, we have K, right? So then how do we figure out what K was?
The way that you're going to figure out what k is using the initial conditions.
We plug in the
Mhm,
two, like, and then
oh, that makes sense.
T equals 1, so we just plug in 1 for T. And
Right, so if b is equal to 2 and t is equal to 1, why is that going to make your life so easy? There's 2 constants. What's the natural log of 1? 0. So
Big C.
So c is equal to 2. So now I've got b equals k times the natural log of the absolute value of t plus 2. Go on to the other initial condition. B is equal to 4 when T is equal to E. All right, B is equal to 4. T is equal to E. Natural log of E. Hopefully another easy one. Natural log of E. 1 times K. K. So 4 is equal to K plus 2, and K is equal to 2. Right, then you're just going to finish it off and say, oh, so B is 2 times natural log of the absolute value of 2 plus 2. What happens when T is equal to 2? We get B equals 2 natural log of the absolute value of 2 plus 2. And those college board folks are being really mean. But this is totally fair game. At the very least, hopefully some process of elimination or good guessing is going to help here. But that answer is not there. Why not? What are they doing to hide that answer from you? Jennifer maybe sees it. We've made it all the way here. The calculus is good. Juan, what do you see?
I think that they multiplied the 2 and both 2.
They multiplied the both 2's?
No, the 2 and
The 2 and this guy in here?
Yeah.
It will get you to 4, but that's not why. It's not that you're multiplying the 2 and the 2. It has to do with log properties, and we talked about this one yesterday. This one's shown up in pre-calc, it's shown up in algebra 2. Noemi, what's the thing that they're doing?
It's supposed to be squared because that's in front of the log.
Right, it's that reverse p in front of the log property, right? You're used to saying log of something to a power, you bring the power down in front. Here I'm saying you get to bring it back up. Please note, b equals 2 natural log of 2 plus 2 is the perfect answer. There is nothing wrong with this answer. Free response, I would want you to stop here. But the reality is in the multiple choice, they might choose to hide it from you in this way. Was number 4 the hard one on last night's homework? I'm curious, how many of you guys really, the struggle place was setting up this differential equation? Okay, that's enough folks there. So you gotta keep in mind if it's, as soon as you see directly proportional, so if you see directly, that means it's y equals k times x. And if it's inversely, then you're saying y equals k times 1 over x. But you've gotta read the stuff that comes before and after the directly and inversely to know what the y is and what the x is. I have no magic beans here. You gotta know rate of change of b with respect to t means dv dt. Alright, so here's what I want to do. I want to stop talking. I want to get you guys some good practice today. So you can put the problem set away. You're not going to work on it anymore today. Instead, what I want to do is give you guys a quick taste of the quiz that is coming on Monday. On Monday, the quiz is going to have somewhere between 6 and 8 multiple choice questions, all of them involving differential equations. Now, some of you might think I just said it's all separable differential equations. That's not what I said. There might be some that are all about this directly and inversely proportional idea. There might be some that are simple differential equations. You just integrate both sides. There will be one. You might want to jot yourself a note here to make sure you know what to do. There will be one where I'm going to say this function is a solution to which differential equation? And what do you do there?
You plug in.
You're really going to work it backwards. You're going to take the function and plug it in to figure out which of the differential equations does it work on. I would make sure that you're comfortable with that. But what I've got for you guys right now, perfect time. That's what I wanted. All right. I've got one question. This is not multiple choice, free response. I would expect everybody in the room should be able to do this in about 3 minutes, completely on your own, no help from anybody. So we're just going to go 3 minutes of silent running, and we'll go from there. Just check. All right, friends, so let's check this out. All right, so start with dy dx equals 2x over y squared. Free response, you're probably going to get a point because they didn't give you the differential equation. You had to do a little bit of work. You're going to separate variables. So I multiplied both sides by dx, and I got y squared times dy equals 2x dx. How many guys are with me so far? This should be like all the friends, right? I'm going to integrate both sides. Integral of y squared, 1/3 y cubed. Integral of 2x, x squared plus c. I'm going to go through and use the initial condition. I chose to use it early. You don't have to use it early. But your final answer should be cubed root of 3x squared plus 27. That would be the 100% all the way right answer. How many guys honestly have cubed root of 3x squared plus 27? Okay, so that's good. I want to be really clear though. This one I would say is like a very comfortable. I would expect most folks are getting this one right. If you're not getting this one right, make sure that you and I are talking before this class period's over. What I want you to do though is we're going to move into some partner practice time. Sorry, let me leave the answers up there for just a little bit. The next ones that we're going to work on for the rest of this period are not going to be the comfortable, easy ones. These are going to be the push questions. So what I need everybody to do is grab your superhero card, whatever superhero you are. Just because you got the Superman doesn't mean that you're my favorite group. It doesn't mean, it's not proof that you're my favorite group. It could be, just some further confirmation. You're going to work with 4 different people. You need to keep this card with you at all times. Whatever superhero you are, you cannot work with that same superhero for the rest of this period. So I need everybody to go and find one other person that you're going to work with, sit with them, get going. Everyone's going to move. And Giselle, if you don't mind, whoever you're working with, can you keep the camera trained on you guys? So we'll do a little bit of like back and forth. You might want to take out your own notebook paper. Shocking, I know. Shocking.
Is it even on right?
All right. Partner
No me
practice.
gusta.
Here we go. Okay, here's how it's gonna work. I am deliberately gonna give you guys some practice time with what I thought would be the hard ones. The ones that involve directly proportional and inversely proportional, you're gonna have to do some reading. There you go. Nice job, Steven Spielberg. You have 1 minute per problem, which is completely on your own. There's gonna be no talking to your partner. This is your 1 minute to read, come up with your plan, start the problem. When the timer goes off, you then have 5 minutes to work with your partner. 1 minute of silence, 5 minutes of work time, and then I'll take any questions and we'll go from there, and then you'll rotate to a new partner.
Oh, you said groups of 4?
Groups of 2.
Oh, alright.
So you have a partner. So Jasmine, you're probably gonna want to go work with David. Everybody good? 1 minute. Partner practice, number 1. Sorry, Jasmine, I think the confusion is that you're gonna work with 4 different people.
Yeah.
That's right. All right, you've got 5 minutes. This is now 2 brains, 1 problem. See where you go with this. I want to come by and check everybody's differential equation, make sure you move in the right direction.
How did you do all that? Square?
Yeah, of you.
I did it. I wrote it like this.
Oh, you're right.
What did you do? Jose, how did you do it that fast?
So is it not?
I mean, I haven't gone that far.
You set up the wrong differential equation.
Which one did you? Oh, you used K times X.
Oh god. Stop. Work. Yeah, because the rate of change is
So instead of
D
X,
over
you
dt.
used U instead of X.
Wait.
All the way.
Oh my god, yeah.
Now what happened to T?
D over dt equals K. And yeah, that's right. And you like do the variable thing.
All 4 of you. Gotta be about.
And then you just find the end of the row.
Just to get the X on the thing. But X is not.
Combine K and C since they're constant. Wait, U is the function, isn't it? U replaces Y.
Yeah, U is Y.
So it's the unity.
Directly proportional
Is it the natural log of absolute value? No?
Because it's U squared.
Negative. Or does the exponent just becomes a negative?
Like this. U is basically the guy.
So negative 1 over X.
So negative 1 over U.
After that, to get C, you just plugged in one of these.
Yeah.
So is one will go for you.
Proportional means it's going to satisfy
Well, you have
this
to
y.
isolate U because that's the Y. You want to have an equation.
You got to know that first.
Oh,
And you have to have T. Where's T?
Y equals K times X.
I mean K.
don't K and aren't both
No.
these constants?
No, that's different. Because K is the constant of proportionality. That's something different from just being a constant. So you have to keep K.
It's not the way, it's not like the way you see
Response that you said.
Can you?
You say, all right. And this is honestly what I'm still doing, like 40-minute review. Directly proportional. There's all the stuff that comes before the phrase directly proportional, and there's all the stuff that comes after the phrase directly proportional. What comes before? The rate of change of U.
Yeah,
with
I
respect
know.
to T. What comes after directly?
It's 1 equals negative 1 over K
Okay, so it's not
times
just
T plus C.
with the variable, you're gonna have to read what's everything that comes before. Okay.
Where's the negative? Negative. It has to be negative. Okay. Yeah, I got that. Plus C.
Okie dokie, hokey pokies.
Nay.
So the tough part that we're gonna keep running into again and again and again, especially with these directly proportional, inversely proportional, you have to be able to read that sentence and pull it apart. And I checked in with 6 or 8 of you guys, and setting up that differential equation is the tough part. Good news, if it's the free response, I will probably keep reading along with you, and I'm gonna say, okay, does David know to multiply both sides by dt? Does he know to divide both sides by u squared? Okay, probably if you're there, you get another point. You're going to integrate both sides. Integral of u to the negative 2 power, add 1 of the power, divide by the new power, you're going to get to negative 1 over u equals kt plus c. To solve for u, right, what did I do? I said, what the heck did I do? What did I do? Right, I can multiply by u and get negative 1 equals kt plus c times u, and then divide. To say that u is negative 1 over kt plus c. I'm curious, how many of you guys honestly made it to u equals negative 1 over kt plus c? Okay, we're moving in a good direction. From here, all you're doing is playing around with those initial conditions to figure out the values. Right, it stops being calculus once you integrate both sides, and now it's just an algebra problem from here. So if all goes well, I get the final answer is that u is equal to negative 1, and hopefully we're good from there. Okay, time to pick a new partner. New partner. Say goodbye to your old partner. This relationship's over. Shoot him the deuces, Jose, whatever you need to do. Choose wisely on this next one. It's harder than the last one.
I need a partner.
Don't just pick a partner because they're good looking. I know everybody wants to work with Edgar. Not everyone can do that.
Yikes.
Somebody has to work with him. This time it's Jennifer. 1 minute of silent work time. You cannot talk to this new partner. Read and go. 1 minute. writing on the cross upside down. All right, real quick, we've got the phrase inversely proportional from the folks that I checked in with. They started off with y equals k divided by x, the rate of change of a with respect to t dA dt equals k times what comes after square root of a. dA over dt equals k over the square root of a. How many guys honestly had that differential equation set up correctly? Okay. Nice. 5 minutes, finish it up. 5 minutes with your partner, help them out. If anybody's not getting this differential equation, now would be a good time to talk to me about this. You both are okay with setting it up? Here, let me move it over here, Giselle, so people can see you more, rather than hiding behind your hair. Okay.
So do we divide by 2/3? Okay.
Oh, we turned it into 1/2.
Good, right? First,
Unless
I
you
would
rewrite it.
rewrite it as a and a half.
Rewrite it as
If you
a
just, you've done so
negative
many, you're like
1/2.
2/3 a to the 3/2.
Yeah. A to the power of negative 1/2.
Yeah.
Oh wait, what? Oh, wait, you have to get it on both sides, like the a still here. So I just multiply it on both sides, a square root, yeah.
And then that turned into a to the negative 1.
Yeah, wait. No, because it's like this, so it's not at the bottom anymore, so you don't have to put the 1/2. The negative, you can just put 1/2.
It's not a by itself, right? You have to multiply it over here. No? Just leave it like this?
Yeah, you have to, you have because you have to find k.
Okay, but so the point I was trying to make earlier is when I see this inversely proportional phrase, that tells me that it's going to be this y equals k over x.
9 to the power of 3 over 2.
All the stuff that comes before is the y. Everything that comes after is what we're calling.
Equals k times 0
The phrase
plus c, right?
inversely proportional.
So C.
No. All of
These two
it.
are the same, right?
Everything that comes
No,
after
because
inversely
you're multiplying by 0.
Oh,
So it comes out.
oh,
So you
okay.
get C equals whatever that is.
Because that's what we're saying.
That,
Those
this
are
is
the
the
inversely.
square root cube, or is it a cubic root square? This square root, it's, I thought it was like that.
This is
Okay, the dA is not constant, the dA is
I think it is. So the square root is 3 times 3.
yeah, until you integrate them two. Just make one happen. Okay, square root of a is the same thing as saying 8.5. And the way that you're integrating,
Yeah, it got
integrate
weird.
something with power, add one to the
I mean, I
power.
got this far. I got like this.
So I agree on this side, it's 2/3
you multiply by,
equals, what's the
is
integral?
it 2? 3 over 2?
I did, yeah, I did 3 over 2. I don't know, basics. I guess, yeah. And you have to like do the square root of.
So for
So
k,
that's what I got. Wouldn't it be the
Yeah,
one
it's
over?
like
Oh, okay.
what's the integral?
So then you use the other one. When C equals 0, A equals 0. No.
For x.
To find for
What's
k,
the
right?
equivalent of k? But not k.
A equals 1, C equals 0.
Like, this
Okay,
is the
so
level
now,
that
yeah,
we're
you have to
playing
find
at.
k.
The things I expect you guys are able to do.
0
All right, so.
k plus 8.
Second,
Wait, what? Come on.
That's good. That's good. Gonna go. Gonna breathe. Go. Bye.
So 0 to power of 0.
Yes, ma'am.
So what do we still? Oh, it'll still end up being 0.
And then K
Yeah,
times 1.
I think
K
it should be.
plus C,
Yes.
which we got to do.
That's what 8 is. Well, 8 of the 3 halves.
Negative 18.
Right. The denominator tells you what you to take. So you would take the square root of A. The numerator tells you what power to rate.
So I did that, and then I felt like, you know how we, like, if
So both right.
something has a exponent like that, we can always, like, square root it by whatever it is. So that's what I did. Because the top is the inside part and then the outside. That's what I did. But it's kind of weird. I don't know.
Is that what you did, like right here?
Yeah. That's what I did.
Negative times.
Negative 18 times 3.
Yeah.
Alrighty.
All three.
Alright, so if all goes well, you guys made it to 2/3 A to the 3 halves equals KT plus C. And from what I saw, most folks made it here. Okay, from there, use the initial condition early. I chose to do that. It made life a little bit easy. You don't have to. You could solve it for A. Either way, you're going to get A is the cubed root of negative 27t plus 27, the whole thing squared. Or cubed root of negative 27t plus 27, big parentheses, squared. What are the questions that are out there before we try a harder one?
So like if we response, can I do this thing? Put 3 over 2 times.
So it's still.
On the free response, can you do 3 over 2 times what?
K plus 18.
K.
Or negative 18.
Where are you seeing that?
Like, you know how you get, like you simplify it? Can I,
Oh, like when you multiply both sides by 3 halves?
yeah, can I just leave it like that?
Please do. If you are not 100% sure that 3 halves times negative 18 is negative 27, then don't do it. Please don't do it. All right, new partner. I'll leave this up here for a little bit if anybody has questions. New partner, really choose wisely. This is the hardest one you're going to do all day. Everybody's got to move.
Who is she? Whoa, that's zoomed in.
All right, problem number 3.
I
We're
got
going
no-
silent running for
Obama.
1 minute. Everybody's completely on their own. Okay, so far I have not seen anybody successfully separate the variables. So I'd love to hear from some folks. What are the issues we're running into? What are the issues, Anthony?
Was next you walk?
Okay, So you're running, like, part of the issue is this x e to the y? Or were you saying you know what you want to do? What do you want to do? Okay, is that legal?
Yes.
Okay. I agree it's legal, is it better? The goal is to separate the variables. I need all the y's and the dy on one side, all the x's and the dx's on another. Mariah, what are your thoughts?
Wait, before.
Oh, you're right.
I'll tell you, Anthony's insight of adding the x e to the y to both sides is spot on the right thing to do.
But you can divide. I mean, yeah, right? Divide the x from the ey. 'Cause it's like-
Divide the x. So you're saying, like, what I hear you saying is you want to divide by x?
Yes.
Okay, is it okay to divide both sides by x? But you're going to have to divide everything by x. And that's going to cause a problem. Adriana, what do you say?
Could you factor out the e to the power of y?
Is that legal? That's legal, right? So there's always like two questions I'm going to ask you though. Is it legal? And does it make it better? Is that better than what we just had?
Yes.
Jonathan, why is that better? Okay. So dy equals e to the y times x plus 2 dx. And I heard you say divide by e to the y. So dy over e to the y equals x plus 2 dx. I'm going to assume that now that we're here, most of you are fine with finishing it off. So take it from here. Don't cheat, don't look up, unless you've done a couple of rounds with this. Okay, what's going on?
Like, haha, JK. Sure.
Yeah, because the natural.
antiderivative is negative.
Mr. D?
Yeah.
Why do you keep the plus C whenever you make the rest of them negative?
Why did I? Good question. So when I multiplied by the -1,
Uh-huh.
I could have done that.
Uh-huh.
The reason that I didn't bother doing that is that C is a constant that I don't know. So the fact of it being negative or positive doesn't actually matter.
Okay.
So that's why I'd make it plus C. We're okay?
Yes.
All right, friends over here. What are the
Let's see if we use E for
Yeah.
So I got 0.0 which Charlie is natural log of C.
Yeah. But on this side, you should have 0.
Yeah.
Okay, and so 0 is equal to negative natural log of C, which I have. And then I said that means that 0 is really just natural log of C. And then I exponentiated both sides. Because that's how you get rid of the element.
So it's
Yeah.
you said natural log of C equals 0, so C has to be 1.
And that's the same thing, right? Because you know the natural log of 1 is 0, you made the leap and said C is equal to 0. That's right.
Oh, that's fine?
Of course.
Oh.
All right, this truly is your last time switching, so if you can find one last new partner.
There's no more problem.
On the front. On the front, there are no more new problems.
Oh my God.
It's okay. It's okay, Edgar. It's a Friday, and we've been together for a while. I have figured you out. There's only 1 or 2 of you that I still haven't figured out. New partner, and it's a word problem. Make sure you pick a reader. Pick a reader. All right, friends. 1 minute. See what you can do.
Hey. All right, friends, we've had some time to read. What are the important things? I'll take anything from anybody. Jennifer, what you got for me?
The temperature and the time are directly proportional.
The temperature and the time are directly proportional. Where are you reading that?
The rate of change of the temperature of the water with respect to the temperature is directly proportional.
The rate of change of the temperature of the water with respect to time is directly proportional to what?
To the difference between the temperature of the water and the temperature of the
Okay, first of all, I know that is the longest directly proportional statement we have seen so far. But what does that actually mean? What does that mean? Knowing me, what does that mean?
you're gonna use y equals k.
Okay, so I know I'm going to have something of the form y equals k times x, but I've got to figure out what's the y and what's the x. What are the two things? You really got to be a careful reader on this one. 3 people, maybe 4. Oh, I'm worried. I'm starting to worry a little bit. Jennifer, what you got?
Y is d degrees of c over d of t.
Okay, according to Newton's law of cooling, the rate of change, which you guys know, derivative, of the temperature of the water with respect to time. How am I gonna write that? Rate of change of the temperature of the water with respect to time. Noemi, how do you underwrite that? I mean, Mariah, sorry.
Would it be D of degrees Celsius over D capital H?
Yeah, so here's where I want to be careful. The degrees Celsius, that's the unit, it's not the variable. So give me the variable. One, what's the variable going to be? dH dt. How did you make that decision? Because they told you? Right, H represents the temperature. dH dt, directly proportional to, what's it directly proportional to? This is the first time I've pushed you guys in this direction. What's it directly proportional to?
The difference between the temperature of the water, which
Difference
is H,
between temperature of the water and,
the temperature of the room.
so it's the difference, which of course means
Subtraction.
subtraction. Difference between temperature of the room and temperature of the water. Temperature of the room. Temperature of the room. Temperature of the room is 20.
20.
Okay, and that is not a constant. Temperature of the water.
Is H.
Temperature of the water is
30.
H. So dHdt is K times all the stuff. K times all the stuff. So there's your differential equation. For those of you that are feeling good with this, finish it off. I'll take on part B with anybody that wants to talk to me about this. At time t equals 10 minutes, the temperature of the water is now 25 degrees. So at t equals 10, temperature of the water is 25 degrees. Using this additional information, solve the differential equation from part A. So for the folks that want to talk to me about this one, what are the thoughts? What are you going to do? Juan, what do you want to do? Multiply by dt. Now I want to be really careful with this. dH is going to be K times big H minus 20 dt. Have you separated the variables? Haven't separated them yet. Mariah, how are we going to separate the variables?
2 divided by H minus 20.
Is that legal? Right, as long as you divide by everything. So I'm going to say that dH over big H minus 20 equals K dt. Nice job. Integrate, integrate. One side's easier, start on that side.
K.
Right, the integral of K dt. I know this group that was back over here, we were talking about this before. The integral of K dt. K is a constant. This has to be KT. Don't write that though. KT plus the constant. So a point for integrating correctly, a point for the C. Now I've got to figure out what the integral of dH over H minus 20 is. Jonathan, what do you think?
Make it H to negative 20 to negative 1.
So H minus 20 to the negative 1 power? Okay, maybe that works. There's nothing wrong with what you just said, but I'm just going to write it this way for a second and see if maybe that connects with anybody. 1 over H minus 20 dH. Jose, what do you see?
Natural log.
Natural log of what?
Natural value
Natural log of H minus 20, and if, double check it, take the derivative. The chain rule says make it 1 over H minus 20, that's good, times the derivative of H, which is 1. So natural log absolute value of H minus 20 equals KT plus C. I would hope that for most of the friends in the room, God bless, now life is good. We're done with the calc. Jennifer, are you okay?
Yeah.
You sure? You've got the face. All right, Jennifer, what are we doing next? I know Edgar knows, that's why I'm calling it Jennifer. You want to get H by itself. How are we going to get the H by itself? Don't make me David, not Edgar. David, what are you gonna do?
You're gonna use the exponent e so that you can cancel it out.
Edgar, what was the word there?
Exponential.
You're gonna, no. Exponentiate.
Oh,
But hey, close, it's close. The e and the ln are inverses. Absolute value of h minus 20 equals e to the kt plus c. Jasmine, what are your thoughts here? We got absolute value of h minus 20 equals e to the kt plus c. Let her breathe. What are the thoughts here?
Plus or minus in order to
In order to what?
get rid of that value.
In order to get rid of those absolute value bars, we're going to do the plus or minus trick here. There's also one other thing that I really hope you're going to do, Adriana.
You can separate e to the power of kt plus c.
Right, this e to the kt plus c, I can pull it apart. And the reason that I would go ahead and do that is now I can say, oh, I've got e to the kt times e to the c, but you guys all know what e to the c is.
Big C.
C.
Super Charlie, don't have to draw that. Okay, big H minus 20 equals plus or minus c e to the k times t. Is everybody okay that I can get rid of this plus minus?
Yeah.
Right, c is a constant, whether it's positive, negative, doesn't matter. Big H minus 20 equals c e to the k times t. Yes, I'm going to add 20 to both sides. C e to the kt plus 20. I am so not done, but we're almost out of time. I need to figure out k. And I need to figure out c. Giselle, what are the thoughts here?
You have the initial condition of at time 0, it's 30 degrees Celsius.
Yeah, all the way back here in the beginning, I didn't do a good enough job flagging this, is that at time 0, the temperature of the water is 30. So let t equals 0, figure out the c. I think if you do this right, you get 10.
Yes.
Okay? Then if you let t equal 10, figure out 25. 25 minus 20 is 5, divide by half, you get like natural log of a half, whatever.
Yeah.
All right, homework this weekend, you already have it. Finish the problem set. As soon as you guys walk in on Monday, we'll have about 10